In this video, we're computing the indefinite integral of tangent to the sixth of x dx. And we're going to start this thing out by splitting off a factor of tangent squared. Now, the whole motivation for this is that tangent squared is involved in a Pythagorean identity that might be useful. So even if you don't see all the details coming up, you try splitting off tangent squared and applying this Pythagorean identity. So just as a quick reminder, this is the basic identity that we have in mind. 1 plus tangent squared x equals secant squared x. Well, this means tangent squared x is secant squared x minus 1. So we make that replacement in the integral. And now we're getting excited because what I notice is when I distribute the tangent to the fourth into those parentheses, I end up with a secant squared multiplying tangent to the fourth. Well, that's a power of the tangent function sitting right next to the derivative of the tangent function. So this takes care of the chain rule. And we should be able to quickly guess the antiderivative of that term. I'm also left with the second term in here that's going to be a minus tangent to the fourth. But that's okay, because what we've accomplished here is one piece that we know how to guess the antiderivative of, and then another piece where it's a power of the tangent function, but it's a smaller power than what we started with, so we know we're going in the right direction. This is progress. So in my next step, I'm going to go ahead and guess the antiderivative of secant squared x times tangent to the fourth of x. Again, that's just a power of a function sitting next to the derivative of that function, and having the derivative of the tangent function in there just tacked onto that term takes care of the chain rule. So what I mean is we can quickly guess that this is 1/5 tangent to the fifth x. And I just mentally check that when I differentiate that thing, I get back to where I started. So you would take the derivative with respect to the tangent of x, bring down that power of 5, canceling the 1/5, leaving me with a tangent to the fourth. And then the chain rule says tack on the derivative of tangent x. So that's exactly what we started with, secant squared x times tangent to the fourth x. My second term is going to require more work. So I have minus the integral of tangent to the fourth x dx. And now all we have to do is repeat the same strategy that we started with. If I split off a tangent squared out of this guy, I can replace it with the secant squared x minus 1. And then I'm going to do all the same stuff. If I distribute that tangent squared, I end up with tangent squared next to the derivative of the tangent function, which is secant squared. And that's a guessable chain rule backwards kind of thing. And then I end up with this leftover term that's going to be just the tangent squared. So I'm going to streamline things a little this time since we're doing basically the same procedure. This first term is a spectator. And then the integral of secant squared x times tangent squared x is going to leave me with a 1/3 tangent cubed. There was a minus sign in front of that integral, so I end up with a minus 1/3 tangent cubed x. Now the second term coming out of this integral is going to be the integral of negative tangent squared x, but there was a minus sign out in front. So I end up with plus the integral of tangent squared x. And there's a dx on there, of course. So the final move here is to just replace tangent squared again with secant squared x minus 1. And so the integral of secant squared x is just tangent x, again, because secant squared is the derivative of tangent. And then we have the integral of negative 1, which is negative x. So in our final answer, we have this 1/5 tangent to the fifth of x minus 1/3 tangent to the third of x plus tangent of x, just the antiderivative of secant squared there, and then minus x. It is an indefinite integral, so we have to have a plus c on there, and we're done. If you enjoyed this video, or at least found it useful, check out another one by clicking one of the links on the left, or click the Zach's Lab logo on the right to explore dozens of physics and math playlists. As always, you can leave your questions, comments, and requests in the comments section below, and I'll get back to you within 24 hours. Thanks for watching Zach's Lab, and best of luck on your math and physics journey.